I am basically unable to talk because Anil kept me out drinking. Nonetheless, I will try and soldier on. My time will be brief, which is good because I'm talking about, in some sense, the most boring of all possible topics, a standard library. A standard library is boring, but fundamentally important. You need a decent one. And there was a time when, if you wanted to use OCaml, think, great, this is a wonderful language. I'm going to go do my next project on it. I'm going to do it. And the first thing I need to do, step one, I need to write a standard library. This is sort of a disaster, right? Lots of people wrote their own, and this sort of continues in many ways. But nowadays, we're at the state where, instead of writing your own standard library, at least you can choose one of the different alternative standard libraries that have been built out. Still maybe not the perfect state of affairs, but considerably better. And core is one of these choices, and I want to very briefly describe kind of where core is, why it's designed how it is, and mostly give you a chance to ask questions about it. I'd say the big difference in the last couple of years is we have started putting significantly more energy in trying to open it up, make it more accessible to people, make it possible for them to see the code in sort of a little bit more as it's coming along, and to make contributions and have those included. And there's still work to making that work smoothly, but we're moving in that direction. So, why? Why are we doing all this? So the first big question is, why do we actually write core? And I think it's in some sense self-evident that we just needed it, right? We had a business, at least it seemed like it was going to be like that at first, but it turns out, after a while, it turned out I wasn't actually just going and staying there for a few months. Really, I was going to be working on this business for a long time, and it required a software stack, and that software stack required improvements to the standard library. Like, I didn't want my list.map map to blow up a large amount of data, right? That was like the first thing I ever did. Like, make things still recursive, and there's lots of other changes that built over time from there, and eventually, we hired some good programmers, and it was turned into a good standard library. So why did we end up releasing it? And I'd say there are really a handful of reasons why it seemed worthwhile to release publicly. One is, we had, at work, grown addicted to it. Right? It was it became part of our human rights, right, as a programmer, was having access to core. And the idea that we couldn't use it externally was as a kind of personal matter for the people who work at GeoStream. And in addition, we thought that it was probably useful to other people. It would be helpful to the community to have it out there. There's no kind of proprietary issues that must be worried about. This terrible secrets we give up by publishing it. So it seems straightforward. Why should you use it? I mean, I think the main argument for core is it is a carefully engineered standard library that is used by 80 programmers who their full-time job is working on programming OCaml, and another, 20 to 40 people who use OCaml some. Like, it is seriously battle tested. It is carefully reviewed and carefully tested, and so there's a fair amount of engineering effort that's gone into that, which hopefully is reflected in the quality of the library. So let's talk about what the pieces are. I think at least some of the pieces, a large subset of the people in this room have used. So one of the core elements of the core suite, right? Core really has there's like a library we call core, but there's a set of things that go together. And one of those pieces are the syntax extensions. So we use CamlV4, and we use it. So we use CamlV4 either a lot or just a little, depending on how you think about it. We write a small amount of CamlV4 code. Right? We do not write lots of CamlV4 syntax extensions because we find it a combination of painful and terrifying to do so. That said, we are absolutely, abjectly dependent on the syntax extensions we have. They're very important in how we write code. I think there's a huge difference in how efficient OCaml would have been for us were it not for these syntax extensions. So the key ones that we had from the very earliest time were sexlib and binprod, where sexlib is a system for creating conversions from OCaml types to S expressions, which we use for simple, low performance messaging and config files. Like the number the number of hours that have been saved from my life of having to write little parsers, I agree, is a huge personal benefit. And bidprod is for fast binary serialization, and we use that for our internal messaging. And again, it's not just that this work is dull, it's also that humans are really bad at write work that's dull, right? So if you have to write lots of completely mechanical things, it's easy and error prone because you're not really going to pay enough attention, right? So for both those reasons, that stuff is really important. There are other things that we've used the syntax extensions to do. For example, we have a syntax extension called PA compare, whose purpose is to automatically generate a comparison function for a type. And we find this to be much better than polymorphic comparing. We try and stamp out more and more uses of polymorphic compare in our systems for two reasons. One is it's slow, and the other is the semantics are wrong. It's just like you get to a node where it's the wrong thing to do a structural comparison, and it does it anyway, and there's no way of stopping it. So we strongly program these types of specialized comparison functions. And again, it's extremely tedious to write them by hand, but having a system generate them for you is lovely. And then, because one of the great things about these is, if you need to override the behavior of this generative capability, you can do it just for the type that you want to override. And we also make a lot of use of that. So the syntax extensions are a big deal, but if you hate syntax extensions, it's fine, you don't need to use them. Core is not designed so that it requires syntax extensions from the user, right? It is sometimes helpful, right? If it is, otherwise you're going to have to write these tedious S expressions converters if you want to use things that require S expression converters. But the library is just a library, right? It's not like we have written things such that it's painful to use core if you don't use syntax extensions, right? So this core itself. So core is, it's in spirit a standard library like many other standard libraries. It's fairly big. It has a lot of different kinds of things in it. It has sort of the standard things you expect, like different container classes. It has also modules for all of the different integer types and floating point types and things like that. It also has lots of structuring components that are used both for core and for other things. So one of the idioms that we really like in core is we want, we hired a guy named Stephen Weeks, who wrote Milton years ago, and has a very unique programming style where he's managed to kind of coerce us into where he really, really, really cares about uniformity. And so much so that it's not enough to just ask people to have uniform interfaces. He really wanted to enforce it. So we made extensive use of these kind of signature components where you want to say you want to be a container, you include the container interface. Right? You want to say that you are comparable or hashable, you include the interfaces that have those things. And so you have very, very strong uniformity in that map is always spelled the same way. It always has the same signature whatever type you're using. And then the last piece is async. So async is a monadic concurrency library, similar in spirit, kind of broadly similar to LWT. There are some fairly significant semantic differences. We are sort of persnickety and very picky about our concurrency semantics. And one of the things that async has to recommend is it is very careful and very precise about the kind of interleavings that you might see. But anyway, I won't talk more about async, I'll be talking more about my other people. So very briefly about design principles here. So everything is people always want everything, but you actually have to make choices, and we've definitely made choices. So one of them, we have a very rough guide to what the choices that are made for are. So consistency over compatibility. We have preferred to make core consistent with itself and have a uniform structure and kind of broadly have the kind of design that we want over making it compatible with a standard library. The shape of OCaml, it is not, right? It makes different choices. If you want to port code one way or the other, you're going to have to change it, right? And there's a balance there. I can see how you could have made the other choice, but that's the one that we made. Correctness over concision. So another tick, another design tick that we have is we care a lot about our code being right for obvious reasons, and so there are lots of design choices you can make. It's like, can I make this very short so that everything is beautiful and tiny, or should I make it explicit so it's easy for the user to understand what's going on? And we try to, as often as possible, choose explicit. One way this shows up is we're very explicit about error handling. So generally speaking, if a function routinely can have an error, it either says _exn in its name, or it returns an option or some other type that indicates the error in this, right? That makes a lot of code longer, right? You have to have these sort of like ugly _exn things that we're throwing exceptions, but you know what? The code that throws exceptions should be ugly, right? Exceptions are ugly, and so you should be careful about them. So, and the other thing I'll say is simplicity over static checks. And it's sometimes hard to rein ourselves into this one, but the thing I like to say about this is that the goal of computer scientists should be to control complexity, and if by adding lots of beautiful static checks, your code has more static guarantees, but it is in the end more complicated, that is a failure. So like, we have tried not to be like too fancy in terms of our use of the type system, and try to keep stuff fairly simple. We still like care about enforcing and think a lot about enforcing guarantees in the type system, but we try and do that without getting overly complicated. Occasionally we give in to our basic desires and use a fancy type here or there, but try to keep that under control. I have basically no time. Let me just say very briefly, in terms of our release process. Yeah. So we have an internal tree, we have an external tree. Sadly, they're not the same. We can't just take our internal tree and export it. It's part of a much bigger process and a much bigger tree that we don't feel comfortable export. So we do have an export on Bitbucket of all of our code, and we have a kind of process for synchronizing back and forth. It's a little bit ugly, and it's not good, but we do use that to export the work that we're doing. And you know, there's a cycle for bringing code in. We've brought in external contributions. It takes a while because we bring it in, we import it to our internal tree, we code review the hell out of it. It takes a while to go through the whole process. And when we're done, it comes back out. So like, it can be a little slow to get new things in, but we are extremely happy to have external contributors. Right? We have some now.
I think you should
all right.
let people ask you plenty of questions.
My apologies. Oh, the weaknesses. Wait. I need help. Could someone ask me what his weaknesses are? So, all right, I'll pretend someone asked me. So, type errors, which we compiled back for core, are terrible. No, instead of calling something an option, it might call something an option.deferred_infix.t or something, and that's actually a very mild case because you have multiple types and they're all 3 times longer than they should be. Jacques has graciously worked on a patch in the compiler, which I think will make this basically go away. We need to get it actually in, but I think it basically steals the heuristics and builds it as well. Documentation is terrible. Documentation is terrible for 2 reasons. One is we internally haven't done a good enough job of documenting it. We need to get better at that. Also, the documentation tools fall down hard on the kind of module-intense design that we use. Like, you know, you want to see what, you know, you look at, it has a comparable interface. There's a little something called comparable, you click on that. And there's another submodule called S, you click on that. And then it's terrible. So, this is the thing that really needs to be fixed. And portability, we are working on this. We have started adding explicit kind of optionality in various functions where you have instead of having this function, you have this function or error, and so that we can do conditional compilation. But portability is still a strain, and it's something where we can definitely use external contributors. All right.
Another quick question?
Another real question.
Perhaps in general, do you prefer functors or polymorphic functions? So is it a matter of functor or polymorphic function?
I mean, we like both functors and polymorphic functions. We don't use any, I'd say the style is fairly normal, right? We use polymorphism most of the time. It's lightweight, it's the easier one to pick. There are some things where you really need functors. Probably the biggest use of functors is when you want, like you have all this standard functionality. You need to build it up. And in some cases you want to build it up automatically. Sometimes you do that with syntax extensions, but sometimes you do that with functors. But not one or the other.
Are you thinking about using JDPs in your code base?
So we're internally building our tree against 3.12.1 and 4 right now. So nothing can go into our tree that uses GAPTs until we drop 3.12.1 support. So and start using 3.4. I think that's going to happen in the next internal release. I think the external release after next, which is going to switch to 4. And there are things where I know people are like chomping at the bit to use GAPTs. But we're not there yet. So the moment people are lamely simulating them on top of first-class modules.
Okay.
descending into advocacy. I think it is extremely well engineered and has interfaces and is designed in a way to use a logical taste. Not mine, this is Steve Weeks' taste. And I mean, I do think it is as a result of being the thing that 80 full-time programmers are using. It's really well developed. It's really well tested. It is a really good standard library, and I don't think there is anything else that has the kind of combination of depth and quality. So I think it's really good.